right, page 519 was your homework, and it had little to do with what we've been working on. Now, it does kind of actually tie back in a moment to what we are going to be doing, but I want to take a look at page 519, review numbers 25 to 33. Review 25 to 33. Bueno. All right, let's go and take a look at these together. Number 25. You're supposed to determine, are these like or unlike terms? And if they are like terms, combine them. Joshua, number 25, are those like terms?
Yeah.
And so they combine to give you?
Negative 4.
Negative 4x. Number 26, Lana, are those like terms?
No.
No, so you can't combine, so your answer would be?
8z squared positive 8z cubed.
Good, 8z squared positive 8z cubed. Can't do nothing. How about number 27, Joshua?
Yes.
So, yes as in yes, they are like terms?
Yeah.
Okay, so what do you get when you combine them?
24p squared cubed.
Here's the thing. In one hand, I've got very big hands, I have 12 p's. In the other hand, I have 12 pq's. Are they the same thing?
Oh.
Right, a p and a pq aren't the same thing, so no, they're not like, because the letters again aren't exactly the same. Now, you could multiply, which would actually give you 144 p squared q, but you can't add them together, so they are unlike. We're just going to have to leave 12p plus 12pq. For redemption, Joshua, number 28.
No.
No, they are unlike, so my answer is?
That.
Yeah, 6m negative 7n. Just lazier than I am. Number 29. I've trained him well. All right, Lana, number 29.
Yes.
Yes, they are like terms, so?
2d to the 4th.
Positive 2d to the 4th. About number 30, Joshua.
Yes.
Yes, they are like. AB and AB are like terms to each other. We combine to get?
4ab.
4ab. Very good. Questions on like terms. Combining like terms. All right, numbers 31 through 33, solving some equations. And Lana, on number 31, I've got a 7m positive 27 equals negative 3m positive m. What did you do first?
Combine negative 3m and positive 4m.
Good. We would normally get rid of any parentheses we see, but there aren't any parentheses. So we'll go ahead and combine our like terms. Nothing on the left-hand side can combine because 7m and 27 aren't like. But negative 3m and positive m are like, which combine to give you?
Negative 2m.
Negative 2m. From this point now, Lana, I've got an m on both sides of the equal sign, but that's no good.
You positive 2m to both sides. You add.
Good. We want to get rid of the little m because I don't like negatives, and if I always get rid of the little one, I'll never have to worry about, almost never have to worry about negatives. What does that leave me with when I add 2m to both sides of the equal sign?
9m positive 27.
Equals 0.
I just put 9m positive 27.
Well, you do still need the equal sign because it's still an equation. We're not done solving yet either, Lana, because I want to find out what m is, right? So now what do I need to do to solve? To get the m by itself. Joshua, help her.
Wait,
You subtract 27 from both sides.
All right, what does that give me?
9m equals negative 27.
Good, now we get the negative 9m, or 9m equals negative 27, and then to finish, Joshua, we simply divide away
9.
to get,
M equals negative 3.
and there's our answer. Questions, Lana, on this one?
I just
Didn't finish it out. Does it make sense what we should have done? All right, let's go to the next one, Joshua. We've got a 12x equal to 3 times the quantity 6 positive 2x. And this time, we do start out with some parentheses. So Josh, what do we need to do with them?
Distribute.
To get?
12x equals, like, simplify or just
Distribute.
3 times 6.
Which is?
18. Positive 6x.
There we go. Distribute the 3 to get 18. Positive 6x. And let's see, then what, Josh? I've got an x on both sides again. That's no good.
you subtract the little x, which is positive 6, and you subtract negative 6 on both sides.
Well, negative 6x.
6x.
There we go, good, from both sides. That'll, of course, cancel over here, giving us.
6x equals 18.
And then we just divide away
6
to get.
x equals 3.
All right, so last one we got negative 3. This time we get positive 3. Lana, did we get this one correct? Excellent. And then Lana, let me come over to you on this next one here. We've got a negative 23q positive 16 is equal to 2q negative 109. Lana, walk us through what we need to do here.
Oh, you gotta subtract negative 2q from both sides.
I could, but that would give me a lot of negativity, right? I don't like negativity. Which is actually the little q, Lana? Negative 23q or positive 2q? Josh? Negative 23 is actually smaller, isn't it? If you're looking at the number line, Lana, here's 0, here's 2, here's negative 23 way back here. Negative 23 is actually much smaller. Now, the instinct reaction is say, wow, 23 is bigger, but it's not a 23. So what should I do to get rid of the little one here, Lana? Good, let's put a positive 23q on both sides of the equal sign. And what does that give me instead? Kind of ignore the work on paper, Lana. Just look up here and talk us through.
25q. 16, yeah. And then negative 109.
There we go. All right, so now, unlike last time where I have 2 q's on both sides, I've taken care of that already, right? The very first step, I took care of getting rid of one of the 2 q's. In this case, it was the negative 23q I got rid of. What now, Lana?
Positive 109 to the 16.
Good. I want to get rid of this q. I want to get this q by itself. Not get rid of it, excuse me, get it by itself. And the 109 is with it, or the negative 109 rather, and the 25. This is less attached, so we're going to get rid of the thing that's less attached by putting a positive 109 on both sides. That'll give us
125 equals 25q.
and then finally finish, Lana, by
Dividing it out, and you get 5.
and there we go. Q equals 5. Or
I
just
still
say 5
got
equals
that
Q.
answer.
You will, but you'll have to deal with more negatives, and I don't like negatives. So that's why I say get rid of the little one. But it's not wrong to move the negative 2q. In fact, you would have ended up with a negative 25q equals negative 125, which still gives you positive 5 for your answer. So it's not wrong, but I've taught students long enough to know every time you have to deal with negatives, there's something you're going to screw up. Kids mess up more with negatives than anything else. So I try to avoid them, just like I avoid fractions. Fractions mess people up. Let's avoid fractions. Let's find ways to avoid tripping hazards, shall we call them. Does that make sense? Good. Questions on these? Been a little while since we worked equations. Going back to the first part of the homework for a moment, you were adding like terms together. And we said you can only add terms that are like. If they're not like terms, as we saw several examples, you can't combine. It's got to leave things as they are. Well, we've been working with radical quantities, irrational quantities lately. And we said in our last lesson that to add radicals together, the radicals have to be like. They have to be similar. What is it that makes radicals similar? 2 requirements. Joshua?
The exponent.
Exponent.
Not the exponent, the indices.
The indices must match. So for instance, if this is a 6th root, this would have to be a 6th root. Okay, what else?
The radicand.
The radicand. So if this is a 5x, then this has to be a 5x. So what's allowed to be different?
The
Number that comes in front, the coefficient that comes in front, maybe an 8, maybe a 3. That's allowed to be different. As long as the actual radical portions are perfect matches, then these could be added together. And in this case, Lana, we would get
11 times the square root of The 6th root of 5x.
We had 11 times the 6th root of 5x, right? Just as if we added an 8m, positive 3m, we get an 11m, and we notice the letter never changes. So the radical never changes in the course of the addition. But you might recall we looked on Friday in our last lesson at an example something like this. The square root of 20 plus the square root of 45. Now here we've got a little problem because these radicals aren't similar. You can't add that unless you first reduce the radical. And these are not written as similar, but if I could reduce the radical, for instance, if I maybe factored a 20 into 5 times 4, or I could take the square root class of the, well, of the 4 to get 2 times the
5.
square root of 5. And maybe here I could factor the 45 into 5 times 9, where I could take the square root of the to get times the, oh, now they're similar. They were in disguise, but now they're visibly similar. Now we can add to get class.
5 times the square root of 5.
And that's what we're going to be working on in this lesson, is taking radicals that on the surface aren't similar, simplifying them down, and then, if they're similar now, going ahead and adding them. In our last lesson, if you look right across the page, page 518, all the radicals were already simplified for us, right? Nothing on page 518 had to be reduced. But as you look at the top of page 519, we come to number 11. Well, here maybe is something that might need to be reduced. Now, number 11, we look at the radicals, and I always look at the easiest radical first. This is the easiest radical. Can I simplify that at all? Can I break down the 2 any smaller? Now, it's already a prime number, so we're done there. What about right here, the 4? Thoughts on the square root of 4?
2.
Well, that's rational. That's just 2. Not the square root of 2 even, just 2. Are these similar radicals to each other? No, in fact, this doesn't even have a radical. Then can I combine them? Nope. There's our answer on number 11. That's all you can do.
So it doesn't have to be.
So in this case, they don't combine, just as 8m and positive 3n wouldn't have combined either. But you don't know that until you simplify it all the way down. Let's look at number 13 together. Let's look at number 13. We've got a 2 times the square root of 3a, and we've got a positive square root of 27a. Lana, let's start by looking at the simplest radical.
3.
The 3a. Can I make that any smaller? Nope, I can't factor up a 3 at all. And 2 does not go into 1 at all, so we can't even simplify the letter. What about the 27a? Thoughts, Joshua?
9.
Oh, okay, we could factor that
To
into 9 times 3 times a.
yeah. Take the square root of 9 to get 3 times the square root of 3a.
Okay, and for now, I'm just going to go ahead and bring down the 2 times the square root of 3a that we were given, since we couldn't do anything else with that. And thoughts, class?
5 times the square root of 3a.
Now they're similar. Now they can combine. And there's our answer. Do you kind of get the feel for what we're doing here? Let's do another one together, number 15. We've got 3 times the cube root of 5x. And we've got plus 3 times the cube root of 10x. What would we have to do to add these radicals? Lana?
Simplify.
You'd have to be able to simplify. You can't add them just right now, get 6 times the cube root of 15x?
No.
No, because they're not similar radicals. So you can't add them the way they're written. The only hope is to simplify, right? Thoughts on how I could simplify this?
The 10, like, reduce the 10 down.
Okay, how would I factor the 10?
2 times 5.
All right, so we've got a 2 times a 5x. Can I take the cube root of 2? How about the cube root of 5?
No.
Is there any other way to factor the 10?
No.
No? Can I simplify this thing at all?
No.
Then can I add this thing at all?
No.
Just circle the problem. You can't do nothing with it.
Oh.
It just doesn't add. Oh well.
Well.
Does that make sense? I'm trying to get you used to the idea of sometimes they just don't add, and that's okay, right? And that's the case that happened here. Just like in the homework, we had some problems that they just don't add. Oh well, it's okay. We move on. Let's look at number 17. We have the square root of 48 and the square root of 27. And Lana, the last problem was singularly disappointing for you. I know you really wanted that thing to work out, and it just didn't. So let me come back to you here on 17 and let you work one that, yes, will work out.
The 27 to 3 and 9.
By the way, let me point out, I'm glad that Lana started, listen, with the 27. It's an easier number to work with. Always start small. Always start with easy. You're going to see why in just a moment, Lana.
The 9 is 3 times 3.
Well, the 9 does factor into
Well,
3 times
3.
3.
So 3 times the square root of 3?
There we go. Let's take the square root of the 9 to get 3 and leave the square root of 3. Now, here's the thought, Joshua. In order for these two radicals to add, do we understand that this would have to be something times the square root of 3? If it is not something times the square root of 3, it don't add at all, right? So when it comes time to factor, I know this can factor into 1 times 48, but I don't care. I know it could factor into 2 times 24, but I don't care. I could factor into 4 times 12. I don't care. 6 times 8, yup, but I don't care. The only thing I care about is if there's a way to do something times 3, because I need a square root of 3 at the end, right? So I'm not guessing how to factor. It had better factor into 3 times a square, or it's no good. What is 48, Joshua? 3 times...
16.
It is. And if that were anything else, if it weren't a square, I'd be like, well, I guess I can't simplify it, but you can. 3 times 16 means I can take the square root of 16 to get
4 times the square root of 3.
There we go. So now I've got 4 times the square root of 3 plus 3 times the square root of 3, Lana, gives us...
7 times the square root of 3.
Do you see how simplifying the easy one gives you a target to aim for? Let me give you an example that's not in your textbook. Suppose we had the square root of 8 plus the square root of, 288.
Oh.
Oh.
Now, one of these is easy and one of these isn't, right? I always like to start with the easy one. So, Joshua, let's start by factoring up the square root of
8.
and let's factor into...
4 times 2 to get 2 times the square root of 2.
Now, we understand there's probably a lot of ways to factor a great big number like this, but the only way I care about is a way that's going to leave me, class, with a square root of 2. So, what number happens to come in there?
144.
Ah, that works out evenly to give me
12 times the square root of 2.
Now, maybe you say, well, I would have seen the 144 in there. Great, maybe you would have. But see, this way it forced you to see it right away. Instead of like, well, I know there's a 9 in there. I don't care about a 9. All I care about is I need a 2 at the end. Does that make sense? What if I'd had a, let's go ahead and leave our square root of 8 for just a moment. And let's suppose I have a 147. Now, 147 actually factors into a 49 times 3. But is that going to help me? No, I'm sure I can simplify it to get 7 times the square root of 3, but I can't add. So I don't care. I know I'm just an uncaring person, but I don't care. I'm no better off here than I was here. Here I couldn't add. Still can't add. Big deal, right? So it's like, okay, it's 2 or bust, right? Once I know I need a 2, I better get a 2. Nope, that don't even divide evenly. Forget it. Now, if the instructions say simplify, then add if possible, well then they got you, because now you have to simplify and get to this point, only to find out you can't do nothing. But our goal, again, in addition, is you have to have the matching radicals. So, oftentimes, not always, but oftentimes you'd be like, well, this came out to a square root of 7. But this one's going to come out to a square root of 7. Let's make sure it matches up. And you can kind of sometimes figure out your factors the easy way. Let's go on to number 19. Number 19. And I've got a square root of 13x cubed plus a square root of 26x cubed. All right. Thoughts on that first radical, Josh?
Well, you can't split it.
Yeah, I can't factor the 13, that's for sure. What about the letter?
No.
What's the index?
2,
What's the exponent?
3.
Can 2 go into 3?
It can.
How many times?
1,
With?
2. Wait. 2. No, 1. My bad.
So I could simplify this a little bit, Joshua. It's not going to work out great, but I can simplify a little bit.
X times the square root of 13x.
Here we go. 2 goes into 3 one time with 1 left over. So that's all I can do there. What about that next radical, Lana?
You can split it into 2 times 13.
All right, and I can take the square root of the? Oh, I can't take the square root of anything, can I? So much for factoring it. If I can't take the square root of a piece, there's no point in factoring it. So for all practical purposes, it don't factor, because it don't factor in a way that helps me, right? It's like walking down the street and there's like a guy that I don't know, and I'm like, hey, that guy's a millionaire. Maybe I'm walking down the street with Glenn, and Glenn's like, hey, see that guy over there? Yeah, he's a millionaire. Do you know him? No. He don't do me no good if you don't know him. Now, if he's your friend and he's in a generous mood, well, now let's talk. But him being a millionaire don't do me no good if you don't even know him, because I know I don't know him. So I need to get to know more millionaires. But anyway, same thing with the 26. I'm like, 2 times 13. That doesn't help me, so I don't care. So anyway, Lana, what about the letters? Anything we can do with the letters?
Yes.
Okay.
You can x times root of 26x.
Are these similar radicals, class?
No.
Yes. Or
No, the radicands aren't the same. They do have the same indexes, both square roots, and they're on the same radicands, so can I add them? No, I'm done. Can't do nothing with them. It's like a dog that isn't trained. You can't do nothing with it. All right, questions? Questions on this? All right, number 21. Thinking of very strange analogies that have very little to do with math class today. All right, we got the square root of 15x squared plus the square root of 60x. And let's see here. Lana, let's start with you this time.
15 can be 3 times
Okay, and you can take the square root of the?
x.
Yeah, that's it. Yeah, I can't take factoring the 15, 3 and 5, big deal, right? But I can do something with the x squared, right?
X times the square root of 15x.
Did you say x times the square root of 15x?
Oh wait, there is no x. There's
Right,
just
no x is left. 2 goes
there
into 2
is.
one time with none left over, so just x times the square root of 15. How about the next radical here, Joshua?
You could do like 15 times 4.
Okay, where you can take the square root of the...
4.
So this time factoring does help. In the case of 3 times 5, that don't help. But in the case of 15 times 4, it helps because you can take the square root of the 4 to get
2
times the...
square root of 15.
And of course, we still have that...
X.
That's still inside the radical, right? We haven't done anything with the x yet.
Oh, the x, yeah.
Right. Can I get that x out of the radical?
No.
No, because does 2 go into 1 at all, class? No. So are those similar radicals, class?
No.
No. I'm done. What if this had been an x squared? Let's just say hypothetically, x squared. Well, now then, 2 would go into 2 class one time with none left over. Now could I add them?
Yes.
Now what would I have gotten?
2x squared times.
Ooh, careful.
3x squared.
Ooh.
Wait.
What's 1x plus 2x? 3x times the square root of 15, right? 1x plus 2x, 3x, and then keep that square root of 15. That would have been my answer had this been an x squared in there. But it wasn't, so we couldn't, so we didn't. Questions? All right, let's take a look at one more before I have you try some of these on your own. Number 23. We got 4 times the square root of 27 plus 3 times the square root of 81. I have to say, most of these, they can't actually combine together. That's really annoying.
Yeah, that is.
It's highly annoying.
Why'd they just give us that?
I don't know. All right. Anyway, to keep you guessing, let's take a look at this one here. Joshua started? No, Lana started last time. Joshua started this time.
Yay. You can factor 27 into 9 times 3.
All right.
Well, with a 4.
Right, 4 times the square root of 9 times 3.
And then you can take the square root of 9 to get 4 times the square root of 3. Wait, what just happened?
What's the square root of 9?
3.
3. So 4 times 3 times the
Square root of 3.
square root of the other 3, right? So this 3 stays in the radical. This square root of 9 becomes a plain old 3 out of the radical, and this 4 just kind of along for the ride, like a third wheel. All right, now what?
12 times the square root of 3.
Good.
And then you take the other one.
Oh, this is Lana's.
Oh.
All right, Lana.
You can factor into 27 times the square root.
You can, but which of those could you take the square root of? So it don't do me no good, so I don't care. All right?
Wait, so just leave it? 12 times the square root of 3 plus 30 times the square root of 81.
I feel like there ought to be something I can do with the square root of 81. It's such a big number. Surely there's a way to
It's not
work with it.
27 times 3.
It is 27 times 3, but I can't take the square root of 3, nor can I take the square root of 27.
Is it 9?
9 times 9? So factor this into the square root of 9 times 9, like that?
Mm-hmm.
Okay. Because which number can I take the square root of? Which 9? Both of them, right? To get...
3 times 3 times this square root.
Not times the square root of 3.
Wait, times 3?
Times 3. Square root of 9 is 3, square root of 9 is 3. Or better yet, Lana. What's the square root of 81?
Wait, 9.
We didn't have to factor it.
Oh.
It's already rational. There we go. Just like square root of 4 is rational, square root of 81 is rational. So this just becomes...
27.
The problem is that a similar radical to this one?
Yes. Yes.
No, because this don't even have a
I mean,
radical.
no.
So can I add them?
No.
Nope. Once again, I'm left unsatisfied and unable to add. Tell you think you're getting smarter and smarter, and you're in like first grade, you can add. You get to 8th grade, and now you can't even add anymore. Like literally can't, not capable of it. All because of irrational numbers. Questions on this? Let's go back and do some of the evens. I want you to do numbers, let's do 10, 12, and 14. 10, 12, 14. Simplify as much as you can, and if you can add them, great. If you can't add them, circle it and move on. You don't have to like it, but just circle it and move on. top of the bottle and bounced off. That sound you heard was the chalk on the bottle. Finished.
Yes, because 14 is 12.
All right, let's take a look at these together. Joshua, what did you do on number 10? Kind of talk me through your thoughts and your actions.
Factor the 28 into 4 times 7, and you can take the square root of 4, which is 2, times the square root of 7, and then plus just bring down the square root of 7 to get 3 times the square root of 7.
Perfect. Did you get the same thing, Lana? Excellent. Look at the next one, Lana. Talk me through.
Take the square root of 25 is 5.
Good. Don't try to factor it. Just take the root. It's rational. It's a perfect square.
And then 50. I tried 5 times 10, but you can't really do the square root of that.
Yeah, neither of those works. Is there any other way to factor 50 besides 5 and 10?
No. Well, 2 and 20. I stopped there.
2 times 25 could have worked, right? Okay. So let's keep working this one and see if we can get it simplified.
5 times the square root of 2.
There we
I guess
go.
you can.
All right. And what do we get when we add 5 squared to 2 plus 5?
5 times the square root of 2 plus 5.
Perfect answer. That. They're not similar radicals. You can't add them. Good. You did not say, I was like, please don't say 10 squared to 2, but I'm going to see if I can trip her up anyway. Nope. Not Lana. Good job, Lana. Did you get this, Josh?
Yeah.
All right, Josh, on the next one, we had 19 times the square root of 3 plus 3 times the square root of 19. Talk me through it.
I just circled it.
Me too.
Yeah.
That's it. Not 22 times the square root of 22. Those aren't like radicals, and they can't simplify. They're all prime, so you can't even factor anything. We're done. Questions on 14. All right, do 16, 18, 20. 16, 18, 20.
It's depressing when you don't even get an answer.
But it's quick. And the lazy mathematician in me is like, I really would have liked something that I could add, but at least it was quick, and I didn't have to waste a lot of time on it. Let's see how we did on these. And this time, Lana, we'll start with you. Number 16, talk me through.
18 was 9 times 2. And then which gives you 3 times the square root of 2.
24.
No matter what way I factored it like 3 times 8. You tried to factor the 8, gives you 2 times the square root of 2 times the square root of 3.
Yeah.
So just,
Well, there is a square in 24. Now, it doesn't work out like, just 2 times 12, you can't take the square root of 12. So I already know I'm not going to be able to actually add these, which is a bummer. But since it said to simplify, what is the only square in 24? 4 times,
6.
so we could simplify it to get,
2 times the square root of 6.
and that's as far as we can go. It doesn't combine after that, but we can at least get that far. Which technically, Lana, you said 3 times 8, which gave you 3 times 4 times 2, which gave you 2 times the square root of 3 times 2, right? Here was your 2, and the 3 that you just had to stay. Well, that is 2 times the square root of 6, isn't it? So, yeah, that's all we could do there. Did you get that far, Josh?
No.
Does it make sense now?
Yeah, when I was doing it, I guess I was acting a little bit dyslexic. And
Okay.
I read it 81 instead
Oh,
of 18.
gotcha.
So I said 9 times 9.
Okay, question. All right, let's come to you, Josh, on this next one. Now, this is a cube root. We're used to square roots, right? We're used to the square root of 4, the square root of 9, the square root of 25, or the square root of 100. Maybe in a weird case, the square root of 49, right? These were kind of our main squares. Well, it's a cube root. We don't have a whole lot of cube roots to go off of, right, Josh? But what's a number we can take the cube root of?
8.
8. Yeah, we can take the cube root of 8. We also could take the cube root any one of
27.
27, maybe a 64, even a 125. But of course, Joshua already identified for 56, we're going to want to factor this into
8 times 7.
to get,
2 times the square root of 7.
not the square root of 7.
I meant cube root of 7.
Yeah, we don't want to forget to copy
Yeah.
down the index, do we? All right.
Then you bring down the other cube root of 7.
To get,
3 times the cube root of 7.
and there we go. And this time they're actually like to each other. They actually add. It's almost a surprise when they do. Questions on this?
I just left it. I just left it like that.
Oh, you missed your chance. Here we go. You've been belly aching about not getting to Adam, and you finally get a chance. You didn't take advantage of it. All right, let's go and go to the next one here, Lana.
The 24. 4 times 6. To give you 2 times the square root of 6x.
Now, we've already got a 2 here, so it's technically 2 times the square root of 6x, isn't it? This 2 comes down, the square root of 4 becomes the 2. So really, we end up with
4
times the square root of 6x. Does that make sense? Okay. What about the other radical?
You just bring it down. I didn't add it again.
So what should we have done?
9 times the square root of 6x.
There we go. And hey, back to back, you can actually add them together.
Add that.
All right, what a pleasant surprise.
I just got all 3 of them.
Okay. Well, it sounds like we didn't finish this one. Did you make it to this point again and stop? So it's just a matter of needing to finish, or maybe didn't multiply the 2s?
Yeah, that, and I probably would have finished it.
Okay. All right, questions at all? Does it make sense now? All right, let's give you 2 more, 22 and 24. 22 and 24. And both of these will work out to actually combine, just giving you a heads up. end on a nice, happy, satisfying
Are
note.
the quizzes and the tests gonna have ones that don't come out?
I'm sure it'll have some. I'm hoping that won't be the majority, because that would be a real bummer. But I'm sure there will be at least one or two that don't. Just given how many are in the text that don't, surely the quizzes and tests will have some that don't.
I don't even know how I made it.
I don't think it's thick enough.
You done?
It won't stand up.
Oh,
Yeah.
I'm not done. I'm
Like, I didn't even fold it.
Satisfying, isn't it?
Not when you're trying to do your work.
You know, it's like I always say, lose some.
You'll lose some.
Wait, what?
Yeah,
Lose some, you lose.
Yeah.
that's just how you
I thought it was you lose some, you lose.
Not in real life. In real life, you lose some, you lose some. I'm a Cardinals fan.
Oh.
All right, let's go and take a look at these last two problems now. Number 22, we have the square root of 20 and the square root of 45, and this looks strangely familiar, like we did this one earlier in the hour, perhaps. Because we know we can factor 20 class into
4 and 5.
and 45 into
5 and 5.
9 and 5, where I can take the square root of a
2.
4 to get
2
times the square root of,
5.
and the square root of 9 to get,
3 times the square root of 5.
and we add to get.
5 times the square
And did you have a feeling of deja vu as you worked it?
I did.
Yeah, we did this earlier in the hour as an example.
Alright.
Let's take a look at number 24. We did not do this one earlier in the hour. We have 5 times the square root of 12 plus 4 times the square root of 75. Lana, start us off.
12 factors and 5 times the square root of 4 times 30. And then the 4 it's 5 times 2 times the square root of 3. So you get 10 times the square root of 3.
All right, Josh, pick up the next one.
The next one you can factor 75, and that's 25 times 3, 74 times the square root of 25 times 3. And then you bring it on the 4, and you can take the square root of 5, so you get 4 times 5 times the square root of 3.
You're going to take the square root of the 25 to get 5. Good.
Yeah, and then you multiply the 4 and 5 to get 20 times the square root of 3.
And Lana, when you add them together, you get,
30 times the square root of 3.
there we go. We end on a high note, don't we, Lana? All right, did you get this answer as well, Josh? Good questions on this. All right, your homework this evening is to do page 520. Page 520. The homework, numbers 1 through 21. Page 520, the homework, numbers 1 through 21. You're going to simplify radicals a lot in the homework tonight. You got several of these where you'll simplify and then try to add if they're like, and if they're not like, then you just whatever. Move on with life. We'll take a look at all of that in our lesson tomorrow.
Have a lot of homework to do.
Have a wonderful rest of your day.
These are study.